This is our exponential versus linear project. The Bahamas have a large population of dolphins. In 2000, there were 1,000 dolphins there. Every 6 months, the dolphin population increases by 10%. So it's the explicit rule is y equals 1,000 times 1.1 to the x power. And you can see our graph right there that shows the incline. And we have a now next equation, and it's now times 1.1 equals next to start at 1,000, and then we have our table of values right there. Okay. How many dolphins will there be in the year 2020? So you have to do y equals 1,000 times 1.1, and since it's every 6 months, you have to do to the 40th power. And the answer to that would be 45,259 dolphins. Okay, now we're going to move on to our linear growth problem. The Bahamas have a large population of dolphins. In 2000, there were 1,000 dolphins there. Every 6 months, the dolphin population increases by 100. So this is linear growth, and the equation is y equals 100x plus 1,000. And you can see our graph right there, and our table values right here. And it's now plus 100 equals next with the start at 1,000. Y equals 100, and since x in this case is 80 because it's every 6 months, 100 times 80 plus 1,000. And the answer to that is 9,000 dolphins. Okay, this is our exponential decay problem.
Funland is a failing amusement park business. In order to avoid bankruptcy, every year since 2005, they decreased their prices by 5%. When they opened in 2005, each ticket was $50 per person. So you start off with $50 per ticket, and each time you have to decrease by 5%. So you use the explicit rule, and it's 50 times 0.95 raised to x power. This is our table of values, and then that's the graph, and this is the next problem. This is for the linear decay problem. Funland is a failing amusement park business. In order to avoid bankruptcy, every year since 2005, they decreased their prices by $5. When they opened in 2005, each ticket was $50 per person. Now, the explicit rule is y equals 5x plus 50, and the recursive is now minus 5, and it starts at $50, which was the original price for the ticket. And each year, you decrease by $5, and that's how the graph is in a straight line, because it is linear. So the question is, in what year will the tickets cost $15? And since each year it's decreasing by $5, you can take from where we left off, which was 2005, and then the value was 25, and you can just keep decreasing till you get there, and that's $15. So by the year 2012, you should be at $15 per ticket. So the question is, how many years would it take for the ticket value to be about $35? And here is the graph, and it starts from 2005 and decreases by $5%. And the equation is 50 times 0.95 raised to x. And you could plug a random number in, or you can plug it into the graph on your calculator. And by the time you get to 7 years, you should have 34.916, and that's around $35 for the ticket value.